Good morning everyone and welcome to Wednesday's maths lesson, which is comparing and ordering fractions less than 1. You know what to do with your starter activity, so pause the video and see if you can reach that target. Okay, let's go through how I got to that target. So our target was 593. This was the method that I used. I did 9 take away, or 9 minus 7, which is 2. Then did 5 minus the 2 that I'd made, which is 3. 25 times 8, which is 200, because 25 times 10 is 250. So 2 lots of 25. Less than that is 200. Then I multiplied it by the 3 that I'd made, which is 600. Then we did 600 minus 7, so we used all the digits there and we reached the target of 593. Once again, there's different ways of doing that. Well done if you reached that target. Right, here's your 4 questions to start with. Complete the equivalent fraction is number 1. Remember, whatever you do to the top, you do to the bottom. That is the rude rule. Write the first 7 multiples of 7. Write the first 7 multiples of 4. So these are numbers that are in those numbers times tables. So 1 times 7 is 7, 2 times 7 is 14, carry on from there. 1 times 4 is 4, 2 times 4 is 8, 3 times 4 is 12, carry on from there. Then what is the lowest common multiple of 4 and 7? What number is the lowest number that's found in both of those times tables? So pause the video, have a go at those, and then we'll go through them. Okay, so we have to convert 2/5 into an equivalent fraction. Remembering the rude rule, whatever you do to the top, you do to the bottom. So to get from 5 to 20, I have to multiply by 4. 5 times 4 is 20. If you times the bottom by 4, you have to times the top by 4. 2 times 4 is 8. Put that in. Let me just erase those. Okay, right, the first 7 multiples of 7. They are 7, 14, 21, 28, 35, 42, 49. 49 is 7 times 7, which is 7 squared. The first 7 multiples of 4. 4, 8, 12, 16, 20, 24, 28. Then it says, what is the lowest common multiple of 4 and 7? So the number that is in both of these times tables, the lowest one. So we get 4, 8, nope. 12 not in there, 16 not in there, 20 not in there, 24 not in there, 28 that's there. So the lowest common multiple of 4 and 7 is 28. Let's move on to comparing our fractions. So we're using the more than, less than or equal sign to compare 3/10 and 7/10. So what is larger or smaller, or are they equal? 3/10 or 7/10. We have 3/10 visualized there. We have 7/10, and you can clearly see 7/10 is larger than 3/10. So 3/10 is smaller than 7/10. This is us comparing our fractions. When the denominators are the same, the greater the numerator, the greater the fraction. So remember that as we're going through our work today. Right. The more than or less than or equal to sign to compare the fractions 2/5 and 7/15. So just have a go at that. Decide, maybe you could write onto a bit of paper. Which way do you think that arrow goes? Or you could make the sign with your hand in front of the screen and see if you're right in a second. Okay, let's have a look. Remember, when the denominators are the same, the smaller the numerator, the smaller the fraction. The denominators are not the same. So here we're converting, so to get from, we need to convert this fraction into 15, so we can compare them. The denominators need to be the same, so you can compare them. So to get from 5 to 15, you multiply by 3. Rude rule, whatever you do to the bottom, you do to the top. So 2 times 3 is 6. So what we're actually doing is comparing 6/15 to 7/15. So 7/15 is larger. Okay, so same idea with these 3 questions. So can you make the denominators the same and compare them? Which one's bigger, which one's smaller? Some of them you might not need to do that. We'll talk about those in a second. So pause the video and see if you can answer those questions. Okay, number 1, if you convert 6 into 18ths, you multiply by 3. Let's just see if the video does it. No, it doesn't. 6 multiplied 3 is 18. What we do to the bottom, you do to the top. 1 multiplied by 3 is 18. So you're comparing 3 18ths to 5 18ths. And 5 18ths is bigger than 3 18ths. Okay, if we want to make fifths into 25ths, you times it by 5. So 5 times 5 is 25. Whatever you do to the bottom, you do to the top. 3 times 5 is 15. And 15 25ths is bigger than 12 25ths. Okay, here you don't need to do any conversions there because you know they're both worth a whole. If the numerator equals the denominator, they're both worth a whole. So you're saying 1 whole compared to 1 whole, so they're equal. Okay, so this chap is saying, I know that 4/7 is greater than 5/11 without having to draw a bar model or finding a common denominator. Do you think that is true or not? If not, why not? And then we'll go through this question. Okay, so we're looking at this question, 4/7 and 5/11. So 7 divided by 2 is 3.5, which is a half, which is bigger than a half, sorry. 11 divided by 2 is 5.5, but smaller than half. So that's one way of looking at it. And then we have another one here, so 8/14 compared to 10/22. So pause it and have a go at this one. Okay, let's have a look. 14 divided by 2 is 7. So 8/14 is bigger than half, so we divide that by 2, we're going to get 7. Divide that by 2, we're going to get 4. 4/7 is a bit bigger than a half. 22 divided by 2 is 11. 10 divided by 2 is going to be 5/11. So that is slightly smaller than a half. So 8/14 is bigger than 10/22. Okay, so let's compare these fractions. So we're going to draw these ones out. So what is the same? What's different? What do you notice? Okay, so 4/9 and 4/5. What's the same? The numerator is the same. The numerator's down here the same as well. However, the denominators are all different. So here we've got 4 divided. We've got 9 bits with 4 coloured, or 5 bits with 4 coloured. So the whole is only divided into 5 here. It's divided into 9 here. 4 parts are shaded. So you can see 4/5 bigger than 4/9. Here we have 2 parts shaded, but the whole is divided into 7 at the bottom, and it's divided into 3 on the bottom on this one. So here you can see that 2/3 is bigger than 2/7. So when the numerators are the same, the greater the denominator, the smaller the fraction. When the numerators are the same, the smaller the denominator, the greater the fraction. Okay, so remembering these facts here, when the numerators are the same, the greater the denominator, the smaller the fraction. When the numerators are the same, the smaller the denominator, the greater the fraction. So if we look at those, so those numerators are the same, so yep, tick, tick. If we compare this one to this one is smaller than this one, and the smaller is the greater the fraction. So this one has to be bigger than that one. because the whole's divided into less pieces. So here, right, bigger or smaller than, to compare the fractions 3/7 and 6/11. When the numerators are the same, the greater the denominator, the smaller the fraction. Is there a way to make those numerators the same? How do you get 3 equals 6? So if you times that by 2, 3 times 2 is 6. Whatever you do to the top, you do to the bottom. So 3/7 is the same as 6/14. So remember, when the numerators are the same, let's see if we put them next to each other. When the numerators are the same, let me just put 6/11 here. I'll put a circle to compare it. The smaller the fraction, so when the numerators are the same, the greater the denominator, the smaller the fraction. So these are the same. This one's greater, so this has to be smaller than this one. So we're going to get it going that way. So we've made the numerators the same, so we can compare those fractions more easily. Okay, so have a go at these, thinking about when the numerators are the same, the greater the denominator, the smaller the fraction. So you need to make equivalent fractions here, so you can make the numerator the same. So what can you do with 3 to make it equal 12? What can you do with 10 to make it equal 20? What can you do with 1 to make it equal 3? So you have equal numerators, so you can compare them more easily. Okay, let's go through these. So 3/10 against 12/37. If you times 3 by 4, you get 12. Whatever you do to the top, you do to the bottom. So 3 times 4 is 12. And you need to do 10 times 4, which is going to be 40. So here we have 12 divided by 40 against 12 divided by 37. So the 12 is getting divided by less here. So that one is going to be bigger. Remembering the numerators are the same, here they are, 12, 12. The greater the denominator, the smaller the fraction. So this one is small. Okay, let's look at this one. So you can approach it 2 different ways here. So you can either times the 10 by 2, or you can divide the 20 by 2. Whatever you do to the top, you do to the bottom. 20 divided by 2 is 10. 62 divided by 2 is 31. So we're comparing 10 31ths to 10 27ths. So which is bigger? 10 divided by 27 or 10 divided by 31? Has to be 10 divided by 27 because it's got the smallest denominator. The last one, 3/8 compared to 1/5. Make the numerators the same. If you multiply 1 by what, you get 3. If you times it by 3, you get 3. Whatever you do to the top, you do to the bottom. So I've times the top by 3, so I have to times the bottom by 3. And 5 times 3 is 15. So we're comparing 3/8 to 3/15. So let's just check that rule again. When the numerators are the same, they are 3, 3. Let's just write that there. The greater the denominator, which one's greater? It's this one. The smaller the fraction. So this is a smaller fraction. So this one is bigger. Okay, so this is a great time to pause and have a go at the questions 1 to 4 on the worksheet. Okay, write these fractions in ascending order. Ascending means going up. So smallest to biggest is another way of saying ascending order. Notice that all the numerators are the same. And the bigger number on the bottom, the smaller the fraction is. Just a reminder, when the numerators are the same, the greater than the denominator, which is the number on the bottom, the smaller the fraction. So which one has the greatest denominator? 5/29. 29 is the biggest number. Which one has the next biggest denominator? 21. 5/21 is second smallest. Then we have 5/11. Then we have 5/6 because it's got the smallest number on the bottom, meaning it's the biggest fraction. Okay, we need to order these from smallest to greatest. So we have 11/16, 5/8, 3/4, and 2/8. So how could we compare these? Have a little think how we could change those fractions to be able to compare them. When the denominators are the same, the greater the numerator, the greater the fraction. So we need to make those denominators the same. So we'll look at putting those into, let's do 16ths. So to get 8 to equal 16, because we want them all to have a common denominator, it will be the same. You times it by 2. Whatever you do to the bottom, you do to the top. So 5/8 is equivalent to, equal to, or the same value as 10/16. What do you think you multiply 4 by to get 16? Multiply it by 4. 4 times 4, 16. Whatever you do to the bottom, you do to the top. 3 times 4 is 12. What do you multiply 8 by? Oh, we've already done that. We know it's times 2. Whatever you do to the bottom, you do to the top. 8 times 2 is 16. 2 times 2 is 4. So now we can really easily compare them. So which one's the smallest one? 11/16, 10/16, 12/16, or 4/16? So 4/16, which is the same as 2/8, is the smallest. And then we've got 10, 11, 12. So 10/16, which is worth 5/8, is the second smallest. And we've got 11 or 12, so 11/16 is the next smallest. And then the last one is 3/4. So remember, when you're comparing them, you make those denominators the same, but then you put the original fractions that you had into the boxes when you're ordering them. Okay, next question. Same again. How can you change those denominators so they're all the same, so you can compare them and put them in order from smallest to greatest? Okay, so if we make them into tenths, 2 times 5 is 10. 1 times 5, whatever you do to the bottom, you do to the top, is 5. So 1/2 is worth 5/10. That's already in tenths. We've got 4/5 here. What do you do to 5 to make it equal 10? You times it by 2. 5 times 2 is 10. Whatever you do to the bottom, you do to the top. 4 times 2 is 8. Is that worth tenths? No, it's not yet. So remember, we've done 5 times 2 to get my tenths. So you do whatever you do to the bottom, you do to the top. So here we have fractions worth 5/10, 3/10, 8/10, and 4/10. So we can see that 3/10 is the smallest. And then, so if we have 3/10 being the smallest, it's worth 3/10. 2/5 the second smallest, because it's worth 4/10. 1/2 being the third smallest, because it's worth 5/10. And 4/5 being the greatest, because it's worth 8/10. And there we go. Okay, last one. How can we do this one? Well, not the last one, the next one. So we need to compare these. 14 33rds, 2/5, 7/9, 3/3. So think about those. How can you compare that? When the numerators are the same, the greater the denominator, the smaller the fraction. So we're only going to look at those three, because you might have noticed that 3/3 is the same as 1/2. None of these are bigger than a whole, so that is going to be the greatest. So we only need to compare these ones. And we can't make the denominators the same, but we can make the numerators the same. So let's make those the same. So to get 2 to 14, you multiply it by 7. 2 times 7 is 14. Whatever you do to the top, you do to the bottom. So you times 5 by 7 as well, and you get 35. What do you do to 7 to make it equal 14? 7 times 2 is 14. Whatever you do to the top, you do to the bottom. 9 times 2 is 18. So now we have the numerators the same, so we can compare them. So we have 3/3, which is worth a whole, so that's going to go in there. We have 14 on the top here. When the numerators are the same, the greater the denominator, the smaller the fraction. Which one's greatest? 33, 35, or 18? So 35 is going to be the smallest fraction, because you're dividing it by the most. 14 divided by 35 is smaller than 14 divided by 33 for that one. But remember, the original one has 2/5, so that is going to be the smallest. Then we've got 14 33rds, or 14 18ths. Well, 33 is bigger than 18, so that fraction is worth less. And then the last one is this one. Just remember that that's 7/9 goes in, not what you converted it to. Okay, let's have a go at this one. Compare those. Can you make the denominators or the numerators the same? Okay, so you can make all the numerators 6. So if you times 1, my pen, 1 by 6, you get 6. Whatever you use to the top, you use to the bottom. 7 times 6 is 42. How do you make 3 equals 6? 3 times 2 is 6. Whatever you use to the top, you use to the bottom. 8 times 2 is 16. What do you do to 2 to make it equal 6? 2 times 3 is 6. So that means you have to times the bottom by 6 as well, by 3 as well. 9 times 3 is 27. So now we can compare them. So which one's got the biggest number on the bottom? 6/42. So that is the smallest, because remember, the greater the denominator, the smaller the fraction when the numerator is the same. So 1/7 is going to go in there. Which one's got the next biggest one? 27, 13, 16. So 27, because it's got the biggest denominator. When the numerator is the same, it is the smallest fraction. So 6/27, which is equal to 2/9, is the next smallest. Then we've got 16 or 13. Well, 16 is bigger, so this fraction is smallest. So 3/8 is going to go next. And then the last one goes in. Excellent. Okay, so here, what is the missing denominator? 6/23 is bigger than 2 somethings, and that is bigger than 8/13. Okay, we need to make something the same so we can compare it. Let's make those into 16ths. Into 16 as a numerator, sorry. So 8 times 2 is 16, then it's the same as this numerator. Whatever you do to the top, you do to the bottom. So 13 times 2 is 26. So we've got 16 over 23, 16 over 26. So what number could go at the bottom? We could have 24 or 25, because 16/25 is smaller than 16/23, but it's bigger than 16/26. So there's your options. Okay, your activity is assigned to you on Teams and Tapestry. So have a go at those. Let us know how you get on. Just remembering the rude rule: whatever you do to the bottom, you do to the top. And if you're comparing, you either need to make the denominators the same, so you can easily compare them using times your dividing to make them the same. Then remember rude rule: whatever you do to the bottom, you do to the top. Or you need to make the numerators the same to compare them. Okay, so if you get stuck, today's been a really good video to pause at the point that you're doing a similar question to on your question sheet, so you can go, oh, that's the method. I've remembered that little bit that I haven't done yet. So if you get stuck, make sure you compare your question to similar ones in the video. Thank you very much for working hard again, and I'll speak to you soon. Bye.